Assalamualaikum everyone. Hope everyone can hear me well. So now we are starting with the review session of P3, and this is the first review session. So first of all, let me write over here that this is the review session, and this is of P3. So the first review session is on Friday, and the next one is on Sunday. Both days it is at 7:30 p.m. and it's approximately 90 minutes long. So now, how am I focusing on these sessions? So let's break it up into two parts. So now today, which I think it's Friday 16th. So now first thing first, that is Friday. Let me focus on differentiation, integration, and differential equations, because these three are interconnected, and little bit of algebra questions we can deal with, little bit of logs, and little bits of trigonometry. So a little bit we can deal it over here. And similarly, this can carry over on the other day, that is Sunday, a day before the exam. So this is 18th May, and this is 16th May. And the focus will be on numerical solution of equation. The focus on Sunday will be on vectors. The focus on Sunday would be on complex numbers. So every single topic is definitely worth it. And that is how we are going to take the things ahead. So now I'm focusing on 2023 yearly papers. And let me start with May-June 2023, the first variant, which is 31. And then we will break it up into the things that we need. So let me just pull this thing over here. It's close by. And now we are looking at this. So 1 year and 1 day. This is what we practiced on one of the platform, online learning platform. So now over here, it says solve this equation. This is log and exponential substitution. So no harm in doing this particular question. So now over here, what do we have? We have this exponential equation, and we have to give the answer correct to 3 decimal places. So therefore, over here, work in 4 decimal places whenever the calculator thing applies. So now, first thing first, we have e raised to power of 2x. That's right over here. We have e raised to power of 2x. So this is what needs to be substituted. Let m is equals to e raised to power of 2x. Therefore, 3m minus 4 over m is equals to this. And 3m squared minus 4 is 5m. You get this thing. This is a quadratic equation. You could either use the factorization, but over here, that was not possible. Factorization was not possible. And then we use the quadratic formula. This value is positive. This value is negative. This we cannot proceed any further, because when we have to take ln of both sides, we cannot take ln of a negative number. We take ln of this side. Now, at this point, you use a calculator. So now over here, calculator usage starts. And then the final answer, I have not shown the 4 decimal place working. I have written down the final answer. But as a student, you have to show the 4 decimal place working. So that thing is done. A modulus question, let's also have a look. Actually, let me just do this thing this way. That yes, the focus will be like this, but let's do one paper. So let's do one paper with everything in it, so that someone who is unable to attend on Sunday for some reason, at least they can have a good look of this. So one paper, complete all topics, and then rest of them, we can go like this: differentiation, integration, differential equation, and the numerical vectors and complex like this, day-wise. So now over here, coming back to this, sketch the graph of y is equals to 2x plus 3 modulus. X-intercept without the modulus. X-intercept, y is equals to 0, x is negative 3 over 2. And then if you want the y-intercept, so if you want y-intercept, y is equals to 3. So that is another thing. So basically the line was going like this. And then modulus is positive, remains positive, 0 remains 0, negative becomes positive. So this is flipped over here. Make sure that the gradient, the steepness remains the same because it's a sketch. Now part B, a lot of people, they ask this question, is it necessary to use part A for part B? The answer is no. It's not stated as such. I personally do it using the algebra way. There are 3 formats on which I work. X modulus less than A, I call it case number 1. X modulus greater than or equal to A, I call it case number 2. Modulus is on the left-hand side. And then the third case, which is mod on both sides. For these 2 cases, that's how I open it up. X modulus is less than or equal to A. Therefore, X lies between negative A and positive A. Got the idea? So that is how this first thing is done. So now over here, make sure that this is written on the left-hand side. First, write it like this. Then this thing goes in the middle and it lies between these 2 values, positive A, and this is negative A. That is how we break this up. So now hold for a second. Let me just highlight this thing. And let me change it into white color. And then we can look at it like this. This thing over here, that is white, and it lies between these 2 values. So now over here, 2x plus 3 is lesser than 3x plus 8. So 2x plus 3 is lesser than 3x plus 8. And that's this blue over here. And the next one is this thing. Negative of this thing is lesser than this. Negative of this thing, I open up the bracket, is lesser than this thing. So this one over here, that is this reddish one. That is like this. And then when we solve, we make x the subject. Make sure when you divide by a negative coefficient, inequality flips. So over here, let me focus on this. The inequality flips. Over here, the inequality flips. Now, when 2 inequalities are moving in the same direction, we apply the true and false test. So let me just focus this thing over here. X is greater than or equal to negative 11 over 5. So let me grab a line over here. And this is negative 5, negative 11 over 5. This is, I don't know why it's not coming out to be straight. So this is negative 5. This is negative 11 over 5. The blue one is x is greater than or equal to negative 5. So the blue one is x is greater than or equal to negative 5. So that goes like this. And it's simply greater than, not greater than or equal to, simply greater. And the red one is x is greater than negative 11 over 5. So therefore, this is x is greater than negative 11 over 5, like this. Now, what we do is that we choose a value from here. We choose a value from here. Which value have I chosen? I have chosen x is equals to negative 3. And the other one, I have chosen x is equals to 0. And I'll plug in the original inequality, which is this. With the side change, that's not an issue. 2x plus 3 modulus. 2x plus 3 modulus is lesser than 3x plus 8. 3x plus 8. Now, if I plug in this value, x is equals to negative 3. 2 into negative 3, negative 6 plus 3, that is negative 3 modulus is it lesser than 3 into minus 3 plus 8. So negative 9 plus 8 is negative 1. And this is positive 3. This is false. This is not true. Similarly, if I choose this value over here, that is x is equals to 0, and I plug it in over here. 3 modulus is lesser than 3 into 0 plus 8 is 3 lesser than 8. Yes, this is true. That means this is satisfying the red inequality. This is not satisfying the blue inequality for this region between this and this. So therefore, the final answer is x is greater than negative 11 over 5. That is how you get this answer. X is greater than negative 11 over 5. That is the final answer over here. That is the true and the false test. So now this thing is done. Let's move ahead. Question number 3, that's binomial. It says find the coefficient of x cube in this expansion. 1 plus 4x raised to power of r. First term is 1. Make sure of that. This is 1. This is nb power 1 over 1 factorial. This is n minus 1. b raised to power of 2 over 2 factorial. n minus 1, n minus 2. b raised to power of 3 divided by 3 factorial. Simplify, you get this. You do selective multiplication. We are interested in coefficient of x cube. The constant from the left will multiply with the x cube. The x from the left will multiply with the x square on the right. And add it selectively, take care of the positive negative sign, we get this answer. Question number 4, what is this about? Question number 4, it says show that the equation can be written in the form this. So now sine 2 theta, you break it up, that is 2 sine theta cos theta. This is an application of double angle formula. And cos 2 theta, there are 3 formats. I chose the first one, that is cos square minus sine square, because I need a cos square over here. I need a sine square over here. So first of all, sine 2 theta plus cos 2 theta. So therefore, the green one is cos 2 theta. I wrote the green one first. That is right over here. Sine 2 theta, the red one, I wrote it over here. And this is 2 sine square theta. I took it to the other side. That's the blue one. And then we simplify, that is very basic, and we get this answer. Hence solve this equation for theta lying between 0 and 180. Now, one thing is that there is cos square, there is sine square, that is sine cos. I divided both sides by cos square theta. So that is one approach. I get this equation in tangent. The other method is that middle term factorization. So it's a beautiful question which can be done with 2 ways. So now this is x square plus 2xy minus 3y square is equals to 0. So this is middle term factorization. You break the middle term and then you take common, and now there are 2 options. So technically I showed both the method, but this is basic trick quadratic in terms of tangent. And this is cos and sine. Sine is equals to cos, tangent is equals to 1, first and third quadrant. Tangent is minus 1/3, write the official thing. Tangent is positive in first and third. Tangent is negative in second and fourth. And then depending upon the scenario, you decide. So because it's between 0 and 180, you don't have to go in the fourth quadrant. You don't have to go in the third quadrant. You find the basic angle. Theta is basic angle in the first quadrant. You find the basic angle. Basic angle is found with the positive ratio. Keep that in mind. Work in 2 decimal places, 180 minus basic angle, and then final answer 1 decimal place. So that is this thing. So first 4 questions are done. Question number 5, just go through it. What does it say? The equation of a curve is this thing where a is a non-zero constant. So expect something like this in the Monday's paper. Something implicit, something with this unknown constant. So let me just highlight it over here. So over here, let me write this thing. That is, this is one of my favorite, implicit. So this is for Monday 19th. So this is a favorite question. So this is implicit with this unknown constant. Okay, let's move on. X square y, that is to be done using product rule. X square derivative of y is 1 dy by dx, and y derivative of x square is 2x. Minus a y square, a is a constant, so minus a as it is. Derivative of y square is 2 dy by dx. Whenever there is a y, in order to make it compatible, so we write dy by dx. That is what we are going to learn at this stage. We don't have to go into some fancy basics. Derivative of a constant is 0. Make dy by dx the subject. You get this thing. When there is a minus at the top, I took a minus common out, cancel off the minus, the sign changes. And that is the first part, because you have to show it exactly like this. Someone asked this question, sir, will you cover entire syllabus? I'm doing a past paper as much as possible, what you can learn from it. I mean, trying my level best. And technically, if you're asking this, will I go over every topic? The answer is yes. That is why I have kept 2 sessions. So again, for some people who joined it right now, this is what I'm focusing on. On Friday, I want to focus on these things. That is today. On Sunday, I want to focus on this thing. Algebra, log, trig could be on either side. But first, the first thing that I'm doing is that first I'm doing one paper completely. And which paper is this? This is May, June 2024, variant 31. This I'm doing complete. And then further questions, I'll do it topically. So now this thing is done. Hence find the coordinates of the point where the tangent is the curve is parallel to y-axis. So remember, if a line is parallel to x-axis, gradient is 0. If a line is parallel to y-axis, gradient is undefined. What makes a fraction undefined? When the denominator is 0. Keep that in mind. So now that is the denominator, 2ay minus x square is equals to 0. And solve it simultaneously with the equation of the curve, because one single equation cannot give you the answer. So therefore, x square is 2ay. So wherever there is x square, I'm plugging it in. So wherever there is x square, I'm plugging this thing in. So therefore, let me just write this thing in green color so that you have an idea what did I plug in. And this is x square is 2ay, that is color, and green. That is what I have plugged in. And then we get y square is 4a square. Therefore, y is positive square root, y is negative square root. And also read the question. Find the coordinates of the points. Coordinates means x and y. Point means points. That is plural. So therefore, it's more than one thing. So bit of English is also needed. So when y is 2a, x square is this thing. Therefore, x is plus minus. And then over here, when y is negative 2a, x square is negative 4a square, cannot take square root of a negative number. So now one y coordinate, 2 different x coordinates. So basically it's at the same level. Technically this is minus 2a, comma 2a. That is this point. And this is positive 2a, that is this point. Vectors, let's read this question first. What is this vectors all about? So now it says relative to an origin, the points A, B, C have position vectors given by such and such. So OA is given, OB is given, OC is given. The quadrilateral is a parallelogram. Opposite sides are parallel as well as equal in length. Find the position vector of D. So either I can say DC is equal to AB. I can say CD is equals to BA. I can say AD equals to BC. I can say DA equals to CB. So I have chosen AB equals to DC. AB equals to DC. What is AB? OB minus OA. What is DC? OC minus OD. Make OD the subject and then you get the answer. The next one, if they were asking for coordinates, we would write it like this. If they are asking for position vector, we can write in the column vector form like this, or I plus I minus 4j minus 3k. That is also the position vector. The angle between BA and BC is theta. Find the exact value of cosine theta. Exact value, focus on that. Cosine theta, they are not asking for the angle. So take 2 vectors diverging from a point BA and BC. So did we find BA over here? We found AB. That is 2, 2, negative 1. Therefore, negative 2, positive 1 is BA. Similarly, we can find BC. Apply the scalar product. Make cos theta the subject. Rationalize, and this is what you are getting. Now, the third part is a very nice question. A very nice question. That is find. Let me again attach that symbol over here. No, not this thing. My bad. This thing. So again, in vectors, a simple but nice question. So again, this is favorite in vectors for your P3 paper. That means they talked about the first thing. They talked about some basic stuff. Then they talked about dot product, also known as scalar product. And over here, we got cosine theta exact value. And guess what are they asking in the third part? They are asking area of triangle or area of parallelogram, something like this. So they are asking, find the area of ABCD. What is ABCD? That's a parallelogram. Give your answer in the exact form. So now, first of all, area of parallelogram, it's 2 times area of triangle ABC. Focus on the diagram again. According to the name, we have drawn a rough sketch. So if I have all the information about ABC, if I have the angle ABC, therefore half into AB into BC, that is the area of this triangle, and double it. Got the idea? So we have cosine theta, the exact value. Let me draw a triangle. So this cosine is adjacent over hypotenuse. Therefore, based upon Pythagoras theorem, I got the height. Based upon the height, I got the value of sine theta. Area of parallelogram, 2 times area of triangle. That is 2 into half into magnitude of one of them. That is root 9. The other magnitude is root 62. So root 9 is 3, root 62 as it is, and sine theta, this is the exact value. Now over here, if I have this exact value, which is root 58 over root 62, root 62, root 62 cancel, 2.5 cancel. So therefore 3 root 58, that is the answer. And this is one of my favorite question of vectors. So now that is till question number 6. Now a differential equation involving trigonometry. Just have a good look. And then I'll go over it. So now it says the variables x and y satisfy the differential equation. X lies between 0 and pi by 4. Condition is given when y is 0, x is pi by 6. Solve the differential equation, obtain the value of x when y is pi by 6. Give your answer correct to 3 decimal places. Now over here, they're not asking for an expression as such. They are asking for evaluation. Now first thing, look at the variable separable. All the y terms on the left, all the x terms on the right. So now, first of all, sine square 3y dy. Sine square 3y dy, that has to be done using double angle, and I have converted. A sine square, this is half 1 minus cosine something. If it's a 3, it's a 6 because of double angle. 4 tangent cosine 2x. So sine 2x over cosine 2x, that is tangent x, 1 over cosine 2x. Now this is sine 2x over cos square 2x. So now no one mentioned that we have to use substitution. We have to make this decision ourselves. So u is cosine 2x and du is negative 2 sine 2x dx. Therefore, only sine 2x dx is negative half du. So 4 is there on the outside. Dx is minus half du. And I have done this working over here. So this is minus 2. 4 into negative half is negative 2. 1 over u squared du. U raised to power of negative 2 du. Now integrate and it comes out to be this. That is the integration that I've shown over here. Have a good look on the right hand side because the right hand side ain't that easy. All clear? Left hand side is basic. Integral of 1 is y. Integral of cos 6y is sine 6y. It is positive. This negative was this thing. And division by 6, division by 6. Y is 0 when x is pi by 6. So c comes out to be negative 4. That is the equation over here. Particular solution because you have evaluated the constant. Now plug in y is equals to pi by 6. Find x. Plug in pi by 6. That was 6 pi, I think, 6 theta or something like that, 6y. So 6 into pi by 6 is pi. Sine of pi is 0. We get the value of x, and that is in decimals right over here. So very strong working is needed. And of course, I'll be going over the examiner report also. Now, some people, they were asking individually also about the things we have done so far. So in my channel, I have focused on especially this year's paper, that is over here, that is May, June, and October, November 2024. And I think I already did February, March a long time ago. So that is of 2024. I think one variant is left. So October, November 2024 variant 33, that will be uploaded tomorrow. And I also solved today, February, March 2025. So that is more than enough past papers. Of course, there are also older versions, some from 2021 or maybe 2022, something like that. So those versions are also available over there. Question number 8. Now this is partial fraction plus integration. So fx is this. The very first thing that you need to check is this thing. Is it a proper fraction or an improper fraction? That is the first thing. The highest power in the numerator is 2. The highest power in the denominator is 3. So yes, it's a proper fraction. It is a linear repeated. So it's a linear expression on the inside, 2 on the outside. So constant over the simple linear factor. And then the square thing is repeated twice as it is with the square. And constants all at the top. And then now this numerator should equal this numerator. That is what you have written over here. You know the substitution technique. You find A, you find C, plug those values in, plug any value, find B, and this is the partial fraction that you get. Now think about it. There are two possible questions that they can make. The first question is they can ask us about binomial. So maybe if something else is coming up, this would be 1 plus 2x raised to power of negative 1. And this would be 2 plus x raised to power of negative 1. Don't forget to multiply with negative 2. This would be 2 plus x raised to power of negative 2. Take it up. Don't forget to multiply by 3 and make sure it's of the form 1 plus b raised to power of n. And if it's about integration, this will give me ln, this will give me ln. This is about chain rule. Have a good look. So now 1 over ax plus b dx, that is 1 over a ln ax plus b plus c. And also let me write chain rule over here. That is integral ax plus b raised to power of n dx. It's valid for every power except negative 1. And it's only valid for linear expression only. Keep that in mind. That is ax plus b raised to power of n plus 1 divided by n plus 1 divided by coefficient of x plus c. So that is the chain rule, and this gives you ln. They are asking us the exact value of this integral between the limit 0 and 4. Give your answer in this form. So always read this thing. Read the question. What is the format that they're asking? 99% of the time, they're asking in the exact form. So now this is focus on this. Over here, the coefficient of x is 2. So this is 1 over 2 ln 2x plus 1. Over here, the coefficient of x is 1. 1 over 1 ln x plus 2. For this thing, you have to take this up. So this is taken up in order for chain rule to be applicable. So this 3 as it is, this is negative 2 plus 1. Let me change the color. Negative 2 plus 1 divided by negative 2 plus 1. Derivative of x is 1. And then you simplify. So first simplify, then plug in. Keep that in mind also. So I need some space over here. Let me grab some paper. Very important detail over here is that first simplify, then plug in the limits, because integration is all about simplification. Simplification is the name of the game. So now over here, you first plug in the upper limit, that is in blue color. So 2 into 4 plus 1 are 4 plus 2. And this is 3 over 4 plus 2. And then you plug in 0. So 0 plus 1, that is ln of 1. ln of 1 is 0. 0 plus 2 is ln 2, 3 over 2. And then sort out all the ln terms together, sort out the fractions together. This is positive, that goes up. This is positive, that goes up. This is negative, so 36 goes down. And then this is also needed. So 3 raised to power of -1. The same type of question was there in today, February, March 2025 paper. I think it was 1 over 108. Over here, it's 1 over 3. And take this minus on the outside, and that is how you write it. Question number 9. This is about integration and numerical solution. Read the question again. What is the technique that needs to be applied? Think about it. The technique that needs to be applied is what? That is by parts. So therefore, let me write the by parts technique over here. That is integral of u dv. That is uv minus integral v du. So remember LATE, this is the order for choosing u, which is the term that needs to be differentiated. So now over here, this is algebra, this is exponential, u is algebra, dv is exponential. What we take as u, differentiate. What we take as dv, integrate. Follow the arrows because the arrows follow the formula. This is uv minus integral, u into v, minus and this minus cancel out, 1 into this thing. So this is positive. Now integrate, take common, and then plug in the limits. So over here, another rule that is the same thing as the application of simplification. Take common whenever, wherever possible, and then plug in limits, and then plug in limits. Show all the steps very clearly. Everything is asked for. So over here, this thing is taken common. There is a minus sign over here. Now with this minus sign, I interchange the position of these two. So this A was the upper limit that became the lower limit. This was the lower limit that became the upper limit because of this negative sign. And then I plugged in, that is e raised to power of 0, 0, 1/4, e raised to power of -2a, half of a plus 1/4 equals to this. Now over here, this 1/4 taken to the other side, that is -1 over 8. This negative cancels out. That is right over here. And then what do I need? I need it in the format a is equals to half ln 4a plus 2. That means I need to get rid of this e. So first of all, I took 8 on this side, I took e on this side, and then I took ln of both sides. And then I made this the subject. So that is the working for this particular question. Verify by calculation, this root lies between such and such. It is necessary. Again, I need to show something. That is, this is change of sign method. So this is change of sign method that it's proving by calculation. Verify by calculation, my bad. So I need this work. So verify by calculation, that is change of sign method. You need to have all the terms on one side equaling it to 0. So fx equals to 0 and then plug in. First, get this thing in this format. So therefore, f of a is this thing. Over here, plug in 0.5, plug in 1.01 is giving me a negative number. The other one is giving me a positive number. And then write the statement. Since there is a change of sign between f of 0.5 and f of 1.0, therefore, the root or solution of equation, that means the same thing, lies between these two values. And then it says, use an iterative formula based on the equation in part 1. So use an iterative formula based on the equation in part 1, determine A correct to 2 dp, give the result of each iteration to 4 dp. So again, it is necessary that you should follow the instruction. So follow the instructions. You cannot say, no, it says on the front cover that work in 4 significant figure, final answer 3 is F. No. Over here, follow what the examiner is saying. Unless otherwise stated in the question. So in the question, it says just follow this, and that's a general rule. So now that equation is this one that we have proven. That is A is equals to something. So now over here, this is your input. This is your output. This is your iterative formula. All you need is some subscripts. So we write it like this: A is half ln 4a plus 2. Underneath it, we write n. Underneath it, we write n plus 1. Between 0.1 and 0.5 and 1, this is the mid value. So the best value to start with. So the best value to start with is the mid value. Or if the examiner says so, use that value. Of course, we cannot argue with the examiner. That is for sure. So when we plug in this value over here, that is 0.75. So show the working: half ln 3 plus 2. That comes out to be this thing, working in 4dp. Then plug in the output. Again, repeat. That's 8261. Then plug in 8261. You get 8343. Plug in 8343. Let me write over here. So plug in 0.8343. We are getting 8374. Now, when the answers are very, very close, rounded off to the required level of accuracy, that is 2 dp. This is 0.83. This is 0.84. 2 decimal places. Yes, they are almost the same. So therefore, do one more step and then stop, because the exact answer is what? 0.84, correct, to 2 decimal places. So now this thing is done, all done and dusted. Question number 10. Now it says the polynomial is this much, and show that x plus 3 is a factor of px. Very simple application. Plug in -3. It should equal it to 0. It's an application of factor theorem. Show that z is such and such is a root of this equation. So the first method is that we carry out long division. So this is method number 1. Now, how do I get this? I think I've done it on the sidelines over here. So I think maybe I wrote it and then erase it. So now, first of all, one other thing is that if I write, which I've not written over here, x minus -1 plus 2 root 6i into x minus -1 minus 2 root 6i. If I multiply these two, I get a quadratic, and the quotient will be x plus 3, the other way around. Now, what have I done? I have written this polynomial divided by linear. I get this quadratic quotient. I use the quadratic formula. I get the roots. The roots are conjugates of one another. Other method is that plug this thing in this cubic equation. So from x cube and x square, I can take x square common out. That is x square, basically x plus 5, and then 31, x plus 75. So plug in x, plug in x, plug in x. That is method number 2. So there were 2 different ways of doing it. Now it says, hence find the complex number z, which are roots of pz square is equals to 0. Now over here, what's the logic? The logic is, if pz is equals to 0, z is this, z is this, z is this. These are the 2 complex conjugate roots, and that is the real root. Now if z square is equals to 0, so therefore all these numbers should be equaling to 0, should be equaling to z square. Before pz is equals to 0, these values equals to z. Pz square is equals to 0, these values equals to z square. So it's a question about square root, and there are 7 marks. 7, 3, 10, 10 and 2, 12. That's a very worthwhile question. 12 marks out of 75, almost 20%. So now z square is -1 plus 2 root 6i. Take square root of both sides. And in the very recent paper, especially in October, November 2024 and in February, March 2025, there are a lot of square root questions. So those who are interested, please go ahead and have a look. I have explained it in very detail over here. It forms a quartic equation, a power 4 equation. So this is a power 4 minus 6 is negative a square. And then I can do the substitution. I can do it beforehand. And over here, these are the answers. So that was this question over here. Also remember this thing, 180-degree rotation, AB becomes negative A, negative B. Coordinates do not flip, they only change sign. That is how the answers of square root look like. So if one answer is over here, one answer is over here, this is related with square roots. Just have a good look. Look at the answer. Positive, positive, negative, negative. Coordinates do not flip, they only change sign. So that is 180-degree rotation. So this thing is done. Let me go to the examiner report, read out the question for you. So we started at 7:30 exact, and this is 8:11 at the moment. So now let me do the underlining. Let's apply some time on it, like 10 minutes or something. So June 2023, variant 1. And let's focus on the key messages. It says, read the question carefully. Make sure answer matches the demand. If it's asking for exact, give the answer in exact form. Take care with basic algebra, extra good care. And arithmetic, because many marks were not awarded due to basic slips. If a question asks for exact answer, then a decimal approximation is not an acceptable substitute. In a show that question, such as such, take extra care with giving full and clear explanation, whether it's about trigonometry, whether it's about integration, whether it's about differentiation, and so on. Do not overwrite one solution with other, as this makes it difficult to read when scanned. So people working in pencil and then overwriting with pen, highly unacceptable. Your work needs to be legible. In particular, the numerical needs to be clear and not ambiguous. So this is some of the key messages. And then let's read over here. Some candidates demonstrated a strong understanding of the topic. However, for the majority, there were many blank responses. Not a good thing. There did not appear to be any particular pattern for this. Maybe some people were finding the difficult, some people were finding the easy difficult. For example, candidates started question 6 vectors, but about 70% gave no response to part C. They were able to connect the dots backwards. In question 9, many candidates attempted the integration by parts, but more than 1/3 responses to B and C were blank. Now, how can anyone leave the numerical solution blank? I have no idea. In question 10, the majority of candidates attempted factor theorem, but then about 1/3 offered no response to part B, the long division or the plugging in thing. More than half gave no response to part C. In general, marks were low with a mean score of 22.6, and a quarter of all the candidates were awarded fewer than 12 marks in total. Let's hope that we don't fall into this category, because the way that I've explained everything and I'm explaining right now, if you follow the instructions, inshallah, you will be doing wonders. So now over here, let me move to the next question. And now this time, I'll just focus on some particular topics, not all. This topic over here, that is inequality. This time, inequality is on both sides. So what do we do? This is case number 3, square both sides. And you actually square both sides. This is not a square root. Keep that in mind. So you actually have to square both sides. You have to square the constant. You form a quadratic equation. You do the factorization. And a quadratic inequality is a must. So x minus something greater than 0. The region above the x-axis, that is right over here. So that is the region above the x-axis. 2 separate region, 2 separate answer. Extreme right, x is greater than 11. Extreme left, x is lesser than 17/11. That is the final answer. Now over here, what happened is that I had a difficult time thinking about the factors. So what I did is that I applied this thing, which is the quadratic formula. I got the 2 roots, 17/11 and 11. And then I wrote x minus, because the coefficient of x square was 11. Ignore that. The root is, we write it x minus p, x minus q. So this is one of the root, this is the other root. That is how we write it. Now, this one, that is an ln thing, nothing special. Let me skip this one. A complex number is for tomorrow. Ignore that. Trigonometry, this is a radian question. Let me go over this. Now it says solve the equation, x lying between 0 and 2 pi, and radians. Make sure calculator is in the radian mode. It can be in terms of pi, it can be in decimals. Final answer 3, significant figure. So now this is half x and this is x. So I converted x according to the double angle formula. Cos 2x is 2 cos square x minus 1. Cos x is equals to 2 cos square half x minus 1. We have this thing, we do the middle term factorization, we get two values of m. Cos x is equals to 1. So from the graph, we know that between 0 and 2 pi, this is half x, so half cycle in 360. So only one value is there, that is 0 radians. Cos half x is negative 3/4, second and third quadrant. Find the basic angle with the positive ratio, that is this thing, 4SF. Half x is pi minus basic angle, that's right over here. Half x is pi plus basic angle. So this is third quadrant and this is second quadrant. Final answer, correct to this much. This is out of the range. Because we have a habit of working till 2 pi, we are working till 2 pi, but now this answer is getting out of the range because of this. So therefore, only one answer from here and one answer from here. Complex number for tomorrow, numerical solution for tomorrow. Implicit, we solve this something like this. Now over here, find the exact coordinates of the 2 points on the curve at which the tangent is parallel to this. So it's neither parallel to x-axis, it's neither parallel to nor parallel to y-axis, it's parallel to this thing. Therefore, gradient is this. dy by dx is negative 2. We get this equation, solve it simultaneously with the equation of the curve. You get two answers for y. Plug those in and you get two corresponding answers. And again, read the question. Find the exact coordinates of the 2 points. There are 2 points. You need exact coordinates. You need x and y. Differential equation. Over here, it says the variables x and y satisfy the differential equation. Just hold for a second. Let me drink some water. My throat is not that good. Now it says the variables x and y satisfy the differential equation. You cannot decide on a technique unless and until you have done variable separable. So dy as it is, dy and 4 plus 9y squared, that is on the left. And 1 over e raised to power of something into dx, that is on the right. So you have to take this up. That's the first thing. The second thing, focus over here. This is 1 over x squared plus a squared. That is 1 over a tan inverse x over a plus c. Now just focus on this thing, 9y squared plus 4. That is 9 common y squared plus 4 over 9. That is 9 common y squared plus 2/3 whole square. And the next thing I'll just show you over here. So first thing is this. Write it like this. That is the first and foremost thing. Because in order to apply this thing, whether it's written in terms of x or y, the coefficient of x squared should be 1. And this should be a square. And then it would be 1 over a tan inverse x over a plus c. So let's just focus on this. This is y squared. This is 2/3 square. That is like a square. This is 1 over 9 into 1 over 2/3 tan inverse 1 over 2/3 plus c. Got the idea? So this is x over a. So x over 2/3, that is 3 over 2x or y, whichever variable is there. Also, this is 1 over 9 into 3 over 2. Let me write this 9 properly. So therefore, this 9 is right over here. So this is 1 over 9 into 3 over 2. This is 1 over 6. Y divided by 2/3, that is tan inverse this thing. So this thing is all done over here and then listed over here. Again, simplification is the name of the game. Over here, open up the bracket, that is negative 2x negative 1. Negative 2 will come out and divide. And then we have a constant of integration. Now you can comfortably watch like this. What is the value? Y is 0 when x is 1. So now I think the space was a bit short. So let me write over here. Y is 0, x is 1, and then we proceed to find c, and c comes out to be this thing. So this is c, that comes out to be this thing. So now this is 1 over 6 tan inverse 3 over 2y minus half e raised to power of this thing plus the constant of integration c. So that is the c. The c is written first. And then this thing. So let me just change it. So this minus is over there. And I wrote the positive thing first and then the negative. Are they asking us expression for y? Yes, they are. So first deal with the e's. This is 1 over 2. This is 1 over 2. This is 6 over here. So 6 into half is 3. 6 into minus half is minus 3. So basically this 3 is taken common up. E raised to power of negative 3, e raised to power of negative 2x negative 1. And this is tan inverse of this. Therefore, 3 over 2y is tangent of this side. And then you make y the subject. Now, what's the next part? I think it's over here. A lot of space was there. State what happens to the value of y as x tends to infinity. Give your answer in the exact form. If x goes to infinity, 1 over infinity. Over here, this is 1 over e raised to power of, this 3 is actually at the top. So hold for a second. Let me just correct myself. This 3 is at the top. That is no issue over here. And e raised to power of minus 2x minus 1, that is e raised to power of 2x plus 1. So this is 1 over e raised to power of 2x plus 1. That is 1 over e raised to power of negative of 2x plus 1. So basically, I wrote it like this. If x goes till infinity, so 1 over e raised to power of infinity plus 1, this becomes very, very, very large. So 1 divided by very, very, very large is very, very, very small. So small that it becomes 0. So this thing is gone. And what am I left with? I'm left with 2/3 tan of this thing. That is the answer for this particular part. So that thing is done. This is partial fraction, basic stuff. Let's look at the integration. This integration is also basic, nothing special. Yes, let's look at this question. This was one tough question. Read the first part. Let me minimize it so I can give some rest to my throat. First, have a good look. Now it says the diagram shows the curve and its maximum point M. Now, first thing first, I'm getting the value of these two x-intercept. That is y is equals to 0. That is the equation of the curve. Y is equals to 0, x plus 5 equals to 0, x is negative 5. And square root equals to 0, x is 3 over 2. So this is 3 over 2, this is negative 5. Find the exact coordinates of M. So M will come out to be negative. You know that from the diagram. Stationary point, dy by dx is 0. Application of stationary point, this is u, this is v. So this is uv prime plus vu prime. This is u, this is u prime. This is v prime. Multiply, multiply, simplify. Our simplification is that taking the square root with the square root. Root a equals to a. And then x is negative 2/3. Perfect. Makes sense. When x is 2/3 negative, plug the value over here. And after rationalization, you are getting this thing. 13 over 9 root 39. They're asking for the exact coordinates. That is the x coordinate and the y coordinate. So that is the answer right over here. Now this one, using the substitution, u is equals to 3 minus 2x. Find by integration the area of the shaded region bounded by the curve in the x-axis. Give your answer in this form where a is a rational number. So the limits are negative 5, positive 3 over 2. So you have to do integration and you have to use substitution. And they have even given us what substitution should we use. U is 3 minus 2x, du by dx is negative 2. Therefore, only dx is negative half du. So dx is replaced with negative half du. You can play around with the constant later on. Square root of 3 minus 2x, that is square root of u. That thing is done. x plus 5. If I make x the subject, that is 3 minus u over 2, add 5 to it. Add 5 to it, simplify, that is 13 minus u over 2. That is 13 minus u over 2. Take this 2 on the outside, take this minus and change the position of these two. So this 2 and this 2 is 1/4. 13 goes up, 0 comes down. Root u into 13. 13 u power half, root u into u raised to power of 3 over 2. So far, so good. Now, the limits. How do I get 13 and 0 from -5 and 3 over 2? Again, using this equation. The limits are for x. I've shown it over here. When x is -5, u is 13. When x is 3 over 2, u is 0. -5 is giving me a bigger number. 3 over 2 is giving me a smaller number. Nothing to worry. That thing is already taken care of. And now this is basic integration, P1. This is basic integration, P1. Simplify, simplify. Now plug in the limits. So now first I plug in 13. So that is, I took common also. That's also one thing. I took root u common. This is u power half. This is u power 2. So because this is 1.5, this is 2.5. So you took half common, this becomes 1. You took half common, this becomes 2. Be very careful with indices. You plug in 13, that is root 13, 26 over 3. And this is 13. This is 2/5, 13 square. You plug in 0, this disappear, this disappear, this disappear. And then it's basic multiplication. 26, I wrote this thing as 2 into 13. I simplified, play it around with this, and then I get this answer. So that is how this question is done. Vectors is for tomorrow. And the next one, that's right over here. Again, let me focus on this one, May, June 2023. This is 23rd April, okay. LN, that was basic. Someone who's not so good with algebraic division, have a good look at this so you can understand. Power 4 divided by power 2. Quartic divided by quadratic. So the rule is pretty simple. That is, take the highest power term, take the highest power term over here and divide, that is 2x squared. And make sure if there is x cube missing, x square missing, x missing, write all of them with 0 coefficient. So that is necessary that you do this. So let me just focus on these 3 like this. And let me change the color. So I wrote them with 0 coefficient so that everything falls into place. 2x squared with each one of them, that is this, this, and this. Change the sign and add, you get these two, you pull this down. Even though it's a 0, pull it down. And then repeat the same process. -2x cubed over x squared, -2x. Repeat the same process. You left with 2 terms, pull this one down. And then the denominator, not the denominator, my bad, the remainder is this, because it's asking for quotient and remainder. So that is the quotient, that is the remainder, that is just basic algebra question. Complex for tomorrow, parametric. Yes, we did some questions on implicit. Now it's time for parametric. Have a good look what's there in parametric. Parametric, x in terms of theta, y in terms of theta, show that dy by dx is this thing. So x in terms of theta, differentiate dx by d theta using quotient rule. And dy by d theta, that is basic integration. And then look at the working. It's for 5 marks. So there is a lot of working for x. Have a good look. Simplify as much as possible. Then divide. So now all this working over here, let's say 2 marks or maybe 3 marks. That is for all this thing. This is dx by d theta. Maybe 1 mark for this and 1 mark for this division. That was pretty basic. Got the idea? This thing and this thing cancels out. Question number 5, even though I think it looks like a numerical solution, let's keep it for tomorrow. Let's keep it for tomorrow. A compound angle, very, very necessary. Cosine A minus B, that's cos A, cos B plus sine A, sine B. Negative gives you positive, positive gives you negative. 3 cos x plus 2 cos x minus 60, we have to write in this form. So first of all, what you need to do is to use the addition formula, that is cos x minus 60. That is why this is written over here. Cos of 60 is half, sine of 60 is root 3 over 2. Simplify. You have a cos term, you have a sine term. You now want to convert it into cos. So if it starts with a cos and if it gets converted to cos, the first term is a, the first coefficient is a, second coefficient is b. So this is a, this is b, and r is Pythagoras theorem. Just take the positive value. Alpha is basic angle. Even if there was a negative sign, this won't change r, this won't change alpha. Yes, if there was a negative sign, the sign would change. Tan inverse of this thing, that comes out to be 23.41. That is how you do the conversion. Now, what's next? Hence, solve this equation. 3 cosine 2 theta. 2 cosine 2 theta minus 60 is 2.5. So this thing over here is what we are using. Instead of x, that's 2 theta. Instead of x, it's 2 theta. So now that format that you have converted, the compound angle, the harmonic form. So x is replaced with 2 theta. Everything else remains the same. It's a P1 question. Make cosine the subject. First deal with the quadrants, first and fourth, because this is positive. Root 19 was positive. Keep that in mind. And then the range, 2 theta lies between 0 and 360. 2 theta minus this thing lies between these two. Basic angle, cos of beta is this much. 2 decimal places. Final answer, 2 theta minus 23.41. That is 55, and 360 minus 45. Make sure it lies within this range. Make theta the subject. That is the final answer, correct to 1 dp. This is a nice question. Have a good look. It says use the substitution u is equals to cosine x. Show that this thing gets converted to this thing. And then how do you integrate this thing? That is integration by parts. So someone cannot prove the first part, at least go to the second part. So this is sine 2x e raised to power of 2 cos x. That is 2u e raised to power of 2u. Now this becomes very messy when we work in u and v and they have used the symbol. So they should use something like m or something. U is this thing, du is this, dv is this thing, v is this. So we are applying late. So this is algebra and trig. So u is algebra and dv is trig. dv is exponential, my bad. The first step, 2u into half e to the power 2u. We get this thing. And this 2 and 2 cancels out. Integrate e raised to power of 2u. That is this thing. First take common, then plug in the limits. That is the blue limit. That is the green limit. Simplify, you get this answer. Now let me show you the substitution part. So now over here, u is cosine x, du is minus sine x dx. So therefore, sine 2x is 2 sine x cos x. And negative du is sine x dx. So let me highlight this. So white color, negative du is sine x dx. So sine x dx becomes negative u du. That is the first thing. Cosine x is u. This 2 remains as 2. E raised to power of 2x is e raised to power of 2u. And then the limits, 0 and pi. So limits also change according to the same equation. U is cosine x when x is 0, u is 1. When x is pi, u is negative 1. And now remember, if there is a negative sign, since they are asking us to prove it, over here, negative 1 is at the bottom. Over here, negative 1 is at the top. How do we change this? Just remove this negative sign. These two will change places. And that is how you have to prove it. So that was a nice question. Again, one of my favorite. So let me write over here. This is again a favorite question of integration by parts with substitution. So it's basically substitution first. It's substitution first, and then it's integration by parts. So let me just reduce the brightness a bit. Another question of this thing, and this also has tan inverse in it. So 2023, they asked a lot of tan inverse in that era. The variables x and y satisfy the differential equation dy and y squared plus 4. and this is y plus 4 also goes up, and dx and x. So y plus 4 over y squared plus 4, this is 1 over x dx. Again, this question right over here, that is one of my favorite integration question, because it has basic ln, it has the second type of ln that gives you ln, and the third one, the tan inverse. So now, as it is, you can do nothing. And again, in February, March, I think something like this was used, either February, March 2025 or October, November 2024, variant 32. Variant 32. Check out one of these. So this is y over y squared plus 4. This is 4 over y squared plus 4. This is 1 over x dx. So 1 over x dx is this. Y over y squared plus 4 with adjustment. 4 can be written as 2. That is the tan inverse. My bad. This is tan inverse, and this is 2y, because derivative of y squared is 2y. We write a 2 over here. In order to balance it, we write a half. So this is half ln y squared plus 4. This is 1 over 1 ln x. C is over here. Now this 4, ignore that. This is y squared plus 2 squared. That is 1 over a tan inverse y over 2. 1 over a tan inverse y over 2. There has to be a positive sign over here. Coefficient of x squared should be 1. And then we plug in the values. X is 4, y is 2/3. So let me write over here. X is 4, y is 2/3. So this y is substituted. This y is substituted. And over here, this x is substituted. So now C is coming out to be 2/3 pi. That's a nice number, because ln 4 cancels out. Again, rewrite the equation. Do we have to make subject? No, we don't. We have to do the evaluation. So half ln y squared plus 4 is 2 tan inverse y over 2 is ln x plus 2/3 pi. That's the particular solution. Y is 2, find x. So y is 2 is plugged in, y is plugged in, ln x, we have to make the subject. Look at all the working. Now at this point, you do the, use the calculator. This is ln x. So therefore, one step, I have not written it. That is e raised to power of ln root 8 minus pi by 6. Are they asking in the exact form, or they did not mention nothing? And are they asking for ln x or x? They're asking for x. So e raised to power of ln 8 root 8 is root 8 minus, this is, first of all, let me write it properly. That is x is equals to e raised to power of ln root 8 into e raised to power of negative pi by 6. That is root 8 e raised to power of negative pi by 6. That can also be written as root 8 divided by e raised to power of pi by 6. So that is giving the answer in the exact form. For some reason, okay, I have done it over here. Okay, exact form is also there. This is the rule that I've applied, this rule of indices that I've applied. So all good, all clear. And let's, vectors is for tomorrow, my bad. Integration partial fractions, binomial. Yes, the long type of binomial. Look at this. And I think that's the last question, because I need to save my energy and voice for tomorrow and day after tomorrow. So I should not overdo it. 2 as it is, this is 1 plus 2x raised to power of negative 1. 2 as it is, 3 minus x raised to power of negative 1. Negative 3 as it is, 3 minus x raised to power of negative 2. Just look at the working. 1 plus 2x raised to power of negative 1. First, second, third term. Simplify, you get this. 3 minus x raised to power of negative 1. The first term has to be 1. Take 3 common out. And this power is applicable on this 3. 3 raised to power of negative 1 is 1/3. Again, simplify the first 3 terms. This is 3 common. Negative 2 is raised to power of 3. That becomes 9. So negative 3 over 9, that is negative 1/3. Again, simplify. And then selectively add it up. So this is 2. This is 2/3. This is minus 1/3. This is 2/3. Focus on negative 4, positive 2 over 9, negative 2 over 9. So this 2 cancels out beautifully. We are left with negative 4x. And then the purple ones, the x squared, 1 over 9, the 2 over 27x squared, the 8x squared, and add it up. And that is how we get this answer. So that is the end of the first session. So the Friday session is done and dusted. So not only we did a lot of working on that thing, that is the whole paper, this thing whole is done. And then over here, May, June 2024, variant 32, variant 33, we have worked all the way up till here. So we will follow the same suit for tomorrow and work in a similar manner. So till the very next class,